Hi, I'm Toby Peck, Director of Outside Plant Broadband Product Management for EnerSys. Excited to be here today talking to you about network power reliability for the SCT virtual cable event. Reliability is vital in the HFC network because the HFC network is the infrastructure that delivers connectivity to customers of all sorts. And especially right now with everything that's going on with COVID, there's not the standard divide that there's always been between business services customers and residential. Everybody's a business service customer. People are working from their homes, and that connectivity is what keeps them working. So that reliability is such a key thing, and there are several factors that can impact that reliability. One is the condition of the network itself, the actual coaxial plant. Another is the health of the batteries that back up in case of any sort of utility health issues. Reliable, robust power conversion that is available via the HFC plant. And then obviously the utility grid itself around the plant. Those are all things, just a few things that can impact the reliability of the plant. You know, power is not flashy, but it's vital to the function of the HFC grid. The U.S. utility grid is not anywhere near as reliable as we generally think it is. In fact, it's generally considered the least reliable grid in the developed world. Reliability doesn't necessarily drive direct revenue for a lot of the MSOs, and so that becomes a challenge in and of itself. But the biggest one is the fact that the HFC plant is such a vast thing. Millions and millions of miles of plant with 750,000 power supplies makes maintaining that a very daunting task. You know, the same thing that makes power reliability difficult for the MSOs is also the thing that gives them a huge asset that has a ton of value in it, and it's the HFC plant. That plant is so vast and has so much coverage that they have the ability to provide power and backhaul to a huge geography. And so as they're looking at new ways to provide connectivity to customers, you know, starting with Wi-Fi, small cell, 5G, IoT, getting into 10G, they have an asset that allows them to provide immense value. And as the DOCSIS network has continued to keep up with the demand for bandwidth, the HFC network continues to be this huge valuable asset, which means the reliability of that is such a big key. Data is really the key to that question. The better information they have, the more they can use that information to target the least reliable sites and really focus on sites that are vulnerable and have a high level of confidence that other sites are going to function and be reliable for as long as possible. And I think a lot of MSOs right now are doing everything they can to pull as much data into the system and understand layer by layer what can lead to poor reliability, use that data to target those non-reliable sites. Our systems offer something we like to use the acronym PREP for. PREP stands for Reliable, Resilient, Efficient Power Supplies with DOCSIS communications that allow that power supply to serve clean power and also be communications hubs for the network. R is remote management. So again, I talked a lot about data. Remote management and monitoring is a huge key to being able to be reliable, understanding what's going on with your system. E is the energy storage, long-lasting, long runtime backup for systems that have some sort of resilience for temperature, and we offer that as well. And then the one that a lot of people don't think about is protective enclosures. This system sits outside, it's the outside plant, and having something that protects that, not just from the elements, but also from potential theft and intrusion, is a huge piece of the value that we offer. And it's this system together that we offer, and the fact that it's all tested and integrated, that we can bring value to our MSO customers with. To get more information on our webinars, trainings, and other events, go to alpha.com/broadband and sign up for email updates and follow us on LinkedIn.